This video is on solving exponent equations. And so for this first example, the directions say to solve the following equations. Notice that these equations are a little bit different than the ones that we have been working with, in the fact that they happen to have an x squared in them. Okay, so instead of just x equaling certain things, we've got x squared. So to undo an exponent, you have to take a root. So if it's an exponent that's squaring a variable, you have to square root that variable. Okay, so what I'm going to do is I'm going to take the square root of both sides. So think about it. What times itself gives us x squared? Okay, that would be x times x. Okay, so the square root of x squared is x, which is what we were trying to do, get down to just a single variable. And then the square root of 16, well, what times itself gives us 16? Well, we know that 4 times 4 gives us 16. Okay, so 4 times 4 gives us 16, but if you think about it, negative 4 times itself also gives us 16. So anytime you're taking a square root, you need to remember the plus and the minus if you are solving an equation with exponents. Okay, so looking at letter B, okay, this is telling us that x is being squared, so I need to undo that by taking the square root of both sides. Again, what times itself gives us x squared? That would be x times itself. Think about what times itself gives us negative 100. Well, the first instinct that a lot of students have is to say negative 10, but the problem with negative 10 is negative 10 times negative 10 is a positive 100. If we do a positive 10 times a positive 10, we get a positive 100. So there is no number that can give us the square root of negative 100. Okay, so instead of getting x equaling an answer to this one, okay, this is not going to be equal, and we would say no solution. Okay, so this would be an example of a no solution. All right, letter C, x squared is equal to 50. Okay, so we're going to square root both sides. Now, if you think about it, we've got perfect squares. We know that 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, we've got 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8, 9 times 9, and 10 times 10. Okay, so if you think about it, 50 doesn't belong in any of those because 50 is not a perfect square. Okay, so your best bet here is to actually leave this as the square root of 50. We cannot evaluate that unless we approximate. So obviously that we have done that here in 8th grade in our 8th grade curriculum is approximating roots. We know that this is really close to, let's see, square root of 59 is really close to square root of 49, which is 7. It's just a little bit over that. So we could try to approximate by saying that this is just a little bit over 7. But when you're just simply asked to solve the equation, we would just need to leave the answer in terms of the square root. All right, let's take a look at example 2. Example 2 just says to solve the following equations. Okay, so same thing here. We've got x squared equals 25 over 100. So the difference on this one is the fact that the right-hand side is actually a fraction. And the nice thing about this is we can do this in about 5 different ways. The first thing that we can do if we want to is we can separate the numerator from the denominator into 2 different square roots, in which case we know that the square root of 25 is 5. We know that the square root of 100 is 10, and that we would get 1/2. Don't forget though, because it's x squared, okay, our answer would have to have a positive and a negative. The other thing that we could have done here is reduced 25 over 100. Okay, we know 25 over 100 is 1/4, and then square rooted, and then separated. Okay, so here we also would have gotten plus or minus 1/2. Okay, so there's a lot of different options here in solving this. Okay, if you're really good with fractions, some people could see that 1/2 times 1/2 would give you 1/4, and where they wouldn't necessarily have to even worry about this step where they're separating those square roots. The next one is not just x squared equaling something. The next one has this +1. So you need to treat this like you do all the other equations. You're always going to add and subtract before you do anything else. Okay, so the first thing we need to do here is we need to get rid of the 1, and we will do that by subtracting. So we have x squared is equal to 49. And now we're ready to square root both sides. Okay, so the square root of 49 is 7. And again, we did do the plus minus. Okay, so we need to have that in our answer. Letter C, we need to get x by itself, so we need to get rid of the exponent 2, the coefficient 2, okay, which is this one right here, this 2. We also have to get rid of the 3, okay? So just like you would solve all other equations, we're going to add 3 to both sides first. And so we're left with 2x squared is equal to 50. And then we can't square root yet because we're not down to x squared. So next thing is, since x squared is multiplied by 2, we're going to divide by 2. So we get x squared is equal to 25. Now we're ready to square root both sides, and we get a plus or minus 5. Example 3, again, just solve each equation. Okay. Now, these 3 examples are a little bit different because instead of having x squared, we have x cubed. So instead of taking the square root, we're going to take the cube root. Now, in the previous examples, when we were taking the square root of something, okay, notice that we did not have to have a number right here. Okay, that number right there is a 2, but it's automatically assumed that it's a square root, that it's a 2, if there isn't anything listed. Okay, that is going to be very different than these problems that we're going to do for part A with the cube roots. Okay, with the cube roots, we can't just write the square root symbol like that because that changes the ballgame completely. And so now you're square rooting a cube and you're not going to get down to x. What you need to do is you need to put a little 3 here to show that you're cube rooting it. And what that means is now you have something times itself 3 times, and that's what you're trying to decide what that is. So x cubed would be x times x times x. Okay, so if I cube root x cubed, I'm going to get x. Well, just like when we solve equations, what you do to one side, we need to do to the other side. Okay, so cube root of 27 would be what times itself 3 times is going to give us 27. Okay, so think about it. That would be 3 times 3 times 3 would give us that 27. Okay, and so 3 would be our answer. Now, you might be sitting there thinking, do we need that plus minus? Okay, well, let's think about this. 3 times 3 times 3, so 3 times 3 is 9, times another 3 is 27. Is that the same as negative 3 times negative 3 times negative 3? Okay, well, we still get 27, but here we have a negative times a negative times a negative. We have 3 negatives. That's going to give us a negative 27. Okay, so in this case, okay, we are not going to be using plus minuses when we're dealing with cube roots. That is only for square roots. All right, letter B. Okay, so x cubed. Okay, we're going to undo that by taking the cubed root. Okay, so what times itself 3 times is going to give you negative 64. Well, that's got to be a negative number. Okay, and then think about it. Okay, 4 times 4 is 16, times another 4 would be 64. Okay, so in this case, the answer would be negative 4. Okay, you can check that by putting negative 4, negative 4, negative 4 in. So this gives us 16 times negative 4, which is negative 64, which is what we have here. And finally, letter C. Okay, letter C, we're going to solve for x. We need to get rid of the 1 first. And so that leaves us with x cubed equaling 27. And then here we need to cube root both sides. So what times itself 3 times gives us 27. That would be 3 times 3 times 3. Okay. All right, when you fill out your Google form, make sure that you read the directions carefully. And remember, please take a picture and upload to Google Classroom. Okay? All right, hope you have a great day.